So far on mole calculations, we've worked with solids and we've done reactive masses and it's all gone nicely. We're now going to look at gases. It's really difficult because obviously a gas, generally we can't weigh gases, do we? We don't say, oh, can you get me 10 grams of oxygen? You go and weigh out 10 grams of oxygen. Normally you work in volumes. So for gases, we use an ideal gas equation to be able to work this out. And you need to know this equation. So the ideal gas equation is PV equals nRT. P is the pressure of the gas in pascals, and V is the volume in meters cubed. And that is equal to N, which is the number of moles you have, times the gas constant, 8.31 joules per mole per Kelvin, times the temperature in Kelvin. Now, where do people mess up for this one? They don't convert it to the right units. So generally in the exam, they won't give you the pressure in pascals, they give it to you in kilopascals. They won't give you the volume in meters cubed, they give it in decimeters cubed or something like that. And they'll give you the temperature in degrees C. So you've got to be confident converting between those units. However, the interesting thing is when you rearrange this equation, which we'll do, I'll just let you wait. So I've started with PV equals nRT, where N is the number of moles. So the number of moles is the pressure times the volume divided by the gas constant of the temperature. And this works for any gas. So it doesn't matter which gas I'm talking about. Every single gas has the same pressure. It only depends on the number of moles that I've got. So it's purely on the number of moles how this works out. So we can use that when we come to do mole calculations for gases, which is what we're going to do with me. So it says find the volume of C2H2 that can be prepared from 10 grams of CaC2 at 20 degrees C and 100 kilopascals. So, what's the first thing I always do? I've been given a mass, so I find the number of moles. So the first thing is moles of CaC2 is 10 grams, and I'm going to divide that by the molar mass of calcium carbide, which is 64.1, and that equals 0.156 moles. I've got that. I then go to my equation. For every one of those, I make one of those. So how many moles of C2H2 must I have? Same, yeah, 1.56. At this point, we would normally find a mass, but we're not going to. We're going to find a volume. So the volume, if I go back to my ideal gas equation, PV equals nRT, so the volume equals nRT over P. So the volume, nRT over P. N is 0.156, R 8.31. The temperature they've told is given as being 20 degrees C, so that's 293 Kelvin. They've told me the pressure is 100 kilopascals, which is 100,000 pascals. So I put those in. So that's times 293 divided by 100,000, and that gives me 0.00380 meters cubed. Yeah, that's fine. Yeah.